All right, welcome to the second video for part 3, finding the derivative using tangent, secant, cosecant, and cotangent rules. The rules are up there at the top of your notes. We'll prove those later. So finding the derivative here, we can use the product rule. We can say f of x is equal to tangent x, and that means the derivative of the tangent is the secant squared. And then g of x is equal to the secant of x, and g prime of x would be secant x tangent x. So y prime is equal to, remember that product rule is f of x times g of x, g prime of x, plus g times f prime. So it's going to be tangent x times secant tangent x plus secant x times secant squared. So then we get tangent squared secant x plus secant to the third. And that is the derivative. So part B is a quotient. And so that means f is the cosecant. So f prime is equal to negative cosecant theta cotangent theta. G is 1 plus cotangent theta. G prime is equal to negative cosecant squared of theta. So remember, it's g f prime minus f g prime all over g squared for s prime of theta. So s prime of theta is going to equal 1 plus the cotangent theta times negative cosecant theta cotangent theta minus cosecant theta times negative cosecant theta, or cosecant squared theta, sorry, all over 1 plus cotangent squared. All right, so then when we distribute, we get negative cosecant theta cotangent theta plus, minus cosecant theta cotangent squared plus cosecant to the third all over 1 plus cotangent theta squared. All right, just rearranging things here, we get cosecant to the third minus cosecant theta cotangent theta minus cosecant theta cotangent squared all over 1 plus cotangent theta squared. And then factoring the cosecant, we get cosecant squared theta minus cotangent squared. Well, actually, let's do it this way. Minus cotangent squared minus cotangent all over 1 plus cotangent theta squared. Cosecant minus cotangent is 1. cotangent theta squared. And then if you just redistribute, you get cosecant theta minus cosecant theta cotangent theta all over 1 plus cotangent theta squared. All right, and that is the derivative for that one. All right, so proving the tangent rule. Proving the tangent rule. That's equal to the derivative of sine over cosine. So we're going to use the product rule, the quotient rule, and we'll get sine squared, because remember, it's g f prime, so it's g f prime, so g is cosine x, f prime is also cosine x, minus, and then it's f g prime, so f is sine x, and the derivative of cosine x is negative sine x, all over g squared. So then you're going to get cosine squared plus sine squared over 1 cosine squared. And notice that becomes 1 over cosine squared, which is equal to the secant squared. So that's how the derivative of the tangent becomes secant squared. For secant, we're going to use the fact that it's 1 over the cosine. So if you do the quotient rule again, remember it's g f prime, so g is cosine, f prime is 0, minus 1 times negative sine, all over cosine squared. So then it becomes sine x, it becomes sine x over cosine squared, which equals sine over cosine times 1 over cosine, which means it's equal to the tangent times the secant. So that's for the secant rule. Cotangent rule, well, that is cosine over sine. So then we once again do the quotient rule. So we get negative sine squared minus cosine squared, because remember it's g f prime minus f g prime all over g squared. So if you factor out a negative, and that becomes negative 1 over sine squared, which is equal to negative cosecant squared. Last but not least, the cosecant rule. It's 1 over the sine, which means it's sine x times 0 minus cosine x times 1 all over sine squared. So it's negative cosine x over sine squared, which means it's negative cosine over sine times 1 over sine. So it's negative cotangent times cosecant. All right. And last but not least, it talks about higher order derivatives. That means like if you take the derivative multiple times. So for example, acceleration was the second derivative of position because it's the derivative of velocity. So if you want to find the fourth derivative, that's what the F4 means. Instead of making hash marks, you're going to just put the number. So that means first derivative, you do 7x to the 6th. Second derivative, meaning taking the derivative again, that's 42x to the 5th. The third derivative, 42 times 5 gives me 210, and x to the 4th. And then the fourth derivative, 210 times 4 is 840, x to the 3rd. Which derivative would result in 0? Well, if you kept doing the derivatives, so the fifth derivative would be something x squared. The sixth derivative would be something x. The seventh derivative would be a constant. So the eighth derivative would be 0. So basically, what derivative will result in 0? It's always one more than the power. So the f to the n plus 1 derivative will always result in 0. So in this case, it's the eighth derivative that will result in 0. All right, I hope you enjoyed the videos, and I will see you next class. Have a good rest of your day.